Hi, my name is Zach Molter, and I'm presenting for CSC570. This paper is titled An Efficient Method to Detect Periodic Behavior in Botnet Traffic by Analyzing Control Plane Traffic. It was written by Basil AsSadhan and Jose M.F. Moura. The abstract of the paper basically states that botnets are a large network of bots that are under the control of master machines. Command and control, I'll call it C2 communications, on a botnet will channel traffic to allow for executing an attack. And then they are analyzing the C2 behavior on the network, and they're attempting to determine whether an attack can give any warning before any harm happens on the network. They do this by determining the periodic behavior of the C2 traffic. Botnets operate on a periodic amount of time that allows them to basically determine whether something happens every X amount of seconds. And they try to contrast that with the standard network traffic over those channels and determine whether they can find the periodic determinations of that C2 traffic that will correlate with those botnets. They applied the test to two different types of botnets, and they verified the results on real traffic obtained from a secured enterprise network. Now, issues with botnets. Botnets are a huge threat. The FBI has identified over 1 million victim computers, and according to the April 2013 Semantic Internet Security Threat Report, 3.4 million distinct bot-infected computers were observed in 2012 alone. Botnets were responsible for about 69% of spam email in 2012, although it is going down slightly. It's still a very major threat. Botnets also include C2 communication channels traffic. That's what they used to help determine what could possibly be tracked down before any harmful malicious attacks occurred. Detection is difficult because of the low volume of command and control traffic, or C2 traffic. C2 traffic is also normally well behaved and does not violate any protocol rules. May only be a few number of botnet members in that network also being monitored, so there may be only a very few bots that are actually putting out that traffic. Makes the periodicness of that traffic hard to detect. And the C2 traffic also may be may be encrypted. Now, for monitoring the C2 traffic, the paper finds that a bot's C2 traffic exhibits that periodic behavior that I was talking about before. Due to the nature of the pre-programmed behavior of a bot, contacting other bots is at a predetermined interval. Periodic behavior is observed when looking at the traffic of the transport port number. As a result of finding out that that is periodic, the detection of that periodic behavior may be an indication of a machine being a member of a botnet. To increase the efficiency of the method, the authors decomposed LAN TCP traffic into control and data planes. This allows them to compare the C2 traffic to the control plane. The approach is to detect a botnet through the detection of its C2 communication channels traffic. This is effective as it detects bots before they engage in malicious activities. The advantage of this technique is that it is a basic property shared by many botnet variants. It's independent of the structure of the botnet, whether it's P2P or centralized, peer-to-peer, and it's also independent of the communication protocol that the botnet uses, IRC, HTTP, etc. This also does not require prior knowledge of certain botnet behavior, so it can be used on any future botnets because of its inherent ability to process the periodic nature of that botnet. How they set up the experiment is they used Slingbot, which is a system for live investigation of next generation bots, to generate samples of botnet C2 traffic. 5 dimensions used for the functionality of botnets are topology, rallying mechanisms, communication protocols, control mechanisms, and command authentication mechanisms. Using Slingbot to set up those 5 bots and 1 botmaster, each bot was programmed to update the data every few seconds by contacting other bots. By plotting this data, they show the sequence of the botnet C2 traffic, and it shows up being periodic. They have a lot of charts and math in this, and I tried to leave that out and just focus on what happened with their experiment. They analyzed the C2 traffic from the bots and the bot master and compared that data to the periodic behavior in the control plane traffic that they analyzed. A bot master can attempt to avoid detection by hiding in the periodic behavior of the C2 traffic. But in conclusion, the method they used by the authors detects periodic behavior in the network traffic, and by determining whether the sample's periodogram peak is significant enough, it then declares the presence of a periodic component. By finding this periodic component, it is able to detect a botnet C2 channel traffic. Basically, by answering the questions required, what is the main contribution? They trying to find out the botnets before they enact a malicious attack on the network. The question the authors want to address is whether they actually can, in fact, determine whether they are able to detect botnets before they attack and how they can use this periodic method. The method they used was to set up sample data sets with their set up their data sets by using their periodic information that they could sample, then compare to the control sample that was then shown to be actually periodically significant, and thus detect the location of the botnets. And the results are that they were able to determine botnet communications prior to an attack. And the overall conclusion means that they were in fact able to determine that the botnets were in fact able to be detected. Thank you for listening. This is Zach Molter. Have a great day.